Hi there. This is going to be a quick little tutorial on our confidence intervals Excel calculator. You can see down at the bottom here we've got several tabs. The first one is large sample mean test. Next to that is a small sample mean test, large sample proportion test, and then two relevant distributions, the z and the t distribution. So if we start with the large sample mean test, anything that is large involves the z distribution and does not involve degrees of freedom. Anything that's small is related to the t distribution and will involve degrees of freedom. And we'll come back to what that means in a moment. All of this is in the interest of conducting hypothesis tests. And we're going to be building on this, but this is our introduction to the topic. So let's look at the first problem here. It says the mean age of graduate students at a university is at most 31 years with a standard deviation of 2 years. Okay, a random sample of 30 graduate students is taken. The sample mean is 32 years and the standard deviation for the sample is 3 years. Are the data significant at the 1% level? So that means 99% confidence. Okay, so state the null and alternative hypotheses. So the null is always going to be no difference when we're doing a means test. And the alternative is that there will be a difference of some kind. All right, so the sample, we're looking at 30. We know the population mean, which we don't always know that, but for this problem we do. And it's 31. The sample mean is 32, and the sample standard deviation is 3. And you can see here I've got three levels of confidence related to the z-score. So at a 90% confidence level, z is 1.65, and this is going to be relevant because it's going to factor into the size of our confidence interval. Okay, z of 95, 1.96, and z of 99% confidence level, 2.58. All right. And the other thing we'll have to calculate will be the standard error. And every confidence interval has a point estimate and a level of confidence tied to a z or a t score and a standard error. And so the margin of error at a 90% level, 95% level, 99% level are going to differ because they're being multiplied by these different values of z. This doesn't change. The standard error is the same. And it is the standard deviation, which in this case is 3 divided by the square root of n for the sample, which is 32. So 3 over the square root of 32 is how we got to that value. You can see the Excel formula there is highlighting those values. And okay, so margin of error, we're just multiplying the standard error, this 0.54 value, by these three different z values. That's why we get larger and larger margin of error. So, to be more confident, we've got to have a wider margin of error. That's one thing just intuitively that makes sense. The smaller the margin of error, the less confident we become that the confidence interval contains the actual population value, in this case 31. So this is what it looks like when we construct the confidence interval based on these margins of error. Okay, so we have a confidence interval for a 90% level, 95% level, and a 99% level. And so we're taking our point estimate for the sample, which is 32, and we're adding or subtracting the margin of error. Right? So for the 90% level, we're adding or subtracting 0.9, and for the 95% level, we're adding or subtracting 1.07, and for the 99% level, adding or subtracting 1.4. And so that's how we got those values. And so the population mean of 31, you can see eh, kind of borderline, almost falls into the 90% level. Um, it does fall at the 95 and the 99% level, right? Depends where we round off. I guess if we round that down, then technically the lower bound is the population mean, so the 90% does capture it, but technically it's a little bit over it. And so this graph here is meant to just help conceptualize that. So you can imagine ages here and the confidence interval being wider or narrower based on how confident we want to be, 90, 95, or 90%, 99%. So the hypothesis test here, confidence intervals include uh, 30, 32%. In most cases, we fail to reject the null. And that should say the population is 31, not 32. All right, so let's fix that. There we go. Plain language, the average age at the university is no different from the rest of the country. All right, so that's a one sample kind of hypothesis test. We're going to look in the future on how to calculate more precisely what the t-value is. Um, so that's something to look forward to in another presentation that will build on these. All right, the next problem, small sample. You can see 15 is in the sample. Same information, basically. Uh, Population mean, sample mean, standard deviation are the same. Now here, we've got to look at the degrees of freedom. So degrees of freedom in this case is n minus 1. So at 14 degrees of freedom, we go to the t-distribution to look up a 90% level. Right, so 14, you can see 1.345 at the 90% one-tail confidence. Usually we're talking about two-tail, but that's how you find your critical values of t. 1.35, 1.76, and 2.62 are the associated t-values that will be used in our margin of error, which is multiplied by the standard error. And same formula for the standard error, the standard deviation divided by the square root of n. So 3 divided by the square root of 15. Down here, we just simply add and subtract the calculated margins of error from the point estimate. So 32 plus or minus 1.04 gives us these values for the 90% confidence interval. Plus or minus 1.36 gives us these values. And plus or minus 2 gives us these values. This next problem is different because it's, instead of looking at numerical values, we're looking at proportions. So the example here, Toastmasters International cites a report by Gallup poll that 40% of Americans fear public speaking. A student believes less than 40% of students at her school fear public speaking, so she randomly surveys 361 schoolmates and finds that 135 report the fear of public speaking. So the hypothesis test we're going to be doing is based on that information. So sample size is 361 from the problem, and x, which is the target, is the number reporting fear. And we know the population proportion is 0.4 based on the report by Toastmasters International. And we calculate the proportion for the sample based on dividing the target by the sample. Right? So we've got 0.37, which you can see is pretty close to 0.4. So the question is whether or not it's close enough to say that there's no difference between the sample and the population. You see below p is q, which is really just another way of saying 1 minus p. Notation varies a little bit on this one. I like to use q just to distinguish it. But there's a little note there saying what that is. So it's just 1 minus this 1.37 is 0.62. Down here we use our z values again. Those are the same as we had before because there are no degrees of freedom associated with the z distribution because it's for large samples. It doesn't change. Down here formula for the standard error is a little different than we saw in the previous examples. It's a square root of p times q, so 0.37 times 0.62, and divided by the sample size, 361. All right, so you can see that in the formula here, we're highlighting the relevant cells, B9 times B10 divided by B6. Okay, that's how we got 0.025. And then the margin of error multiplies the standard error, 0.025, by the different z values associated with the 90, the 95, and the 99% confidence levels. And the associated margins of error also come into play down here, right, where we look at the confidence interval. So at the 90% level, we're adding and subtracting 0.04 to 95, we're adding and subtracting 0.049, and 99, we're adding or subtracting 0.31 roughly. And you can see that 0.4 does fall within the ranges at each level. So in other words, then the hypothesis test, the confidence interval, specifically we're supposed to be looking at the 95% level, but even at the other levels does include 40%, so we fail to reject the null hypothesis that the school is different from the rest of the country. So that's what the plain language conclusion is. Their school is no different from the country on the proportion fearing public speaking. All right, thank you.